Okay, so continuing with probability, we're going to look at tree diagrams today. So hit pause, get the heading, lesson objective, and the keywords down. Write starter on the line. When you're ready, we'll move into the starter. Okay, so here's our starter for today. Hit pause, have a go at 3 questions. When you're ready, hit play and we'll go over them. Okay, so we're going to share £240 in a ratio of 5 to 3. So if we use the 3 steps, hopefully you remember that. Add, divide, and multiply to share in a given ratio. So we add the ratios, 5 add 3. So we're going to share 240 into 8 parts. So we can divide the 240 by 8. Tell us how much each share is, and that 8 goes into 240 30 times. So we multiply 5 by 30, it's £150, and 3 by 30, which is £90, giving us, if we check, our total is 240. Okay. Question number 2, factorize. So we want to factorize this quadratic. So we're going to have double brackets here. We've got x squared, makes it nice and simple for us. So it'll be x times x. We've got minus 56. So we want to find the factors of minus 56 that can give us 1. Well, minus 1. So that's going to be, it's got to be 8 and 7. Because 8 take away 7 gives us 1. Because it's minus 1, the 8 is going to be negative and the 7 is going to be positive. So 8 plus 7 and 8, x minus 8. So that implies then that either x plus 7 equals 0, or let's just separate this, or x minus 8 equals 0, which means that either x is equal to minus 7 or x is equal to 8. And for this question here, this is a dots question, difference of 2 squares, so that's going to be x plus 7 is 49, the square number, and x minus 7. So that implies that either x plus 7 is equal to 0 or x minus 7 equals 0, which means either x is equal to minus 7 or x is equal to positive 7. And then question 3, we've got to express 300 as the product of prime factors. So if we take our 300 prime numbers, let's start with the smallest prime number, 2 and 3, 5, 7, 9 isn't, 11, 13. I think that'll do for now. If we need to increase, we'll do so. So we always check with the smallest number, 2. Does 2 go into 300? Yes, 150 times. Try again. Does 2 go into 150? Yes, 75 times. Now 2 doesn't go into 75, so we try 3. If I add 7 and 5, I get 12. 3 goes into 12, so 3 definitely goes into 75. And that's going to be 25 times. And 25 is 5 times 5. So those are our prime numbers. So 300 is equal to 2 squared, 2 of them, times 3 times 5 squared. Okay. So hit pause in a second, make your corrections, and rate your work. Once you've done that, hit play again and we move on. So hit pause now. Okay, so probability trees. We're going to be looking at independent events in the first instance. So Peter has 10 colored cubes in the bag, 3 are red, 7 are blue, and he removes a cube at random, notes the color, and then replaces that. That's very important. Because he replaces it, Each event is independent of each other. He then chooses a second cube at random, record the information in the tree diagram. Well, when he chooses, he can either choose a red or a blue cube. So he could select a red or a blue cube. Probability of selecting a red cube, there are 3 red out of the 10 altogether, is 3 out of 10. Probability of selecting a blue cube is going to be 7 out of 10. If he selected a red in the first instance, he then goes on to select another cube. So it could be red and it could be blue again. And after he selected a blue cube and replaced it, it could be a red or a blue cube again. Probabilities are the same because he's replaced the cube, so he's still selecting out of 10. 7 out of 10. Probability of red is 3 out of 10, and blue is 7 out of 10. And this is how we label our tree diagram. So that's our tree diagram completed. Now if we wanted to find out the probability of him selecting a red followed by a red cube, we could write P, red and red is going to be equal to 3 out of 10 times 3 out of 10, which is 9 out of 100. If he was going to select a red cube followed by a blue cube, probability of that would be red and blue, which would be 3 out of 10 times 7 out of 10, which is 21 out of 100. If it was going to be the other way around and he selected a blue cube first, then a red cube in the second instance, that's going to be probability of blue and red, which is the second one inverted, so it's going to be 7 out of 10 times 3 out of 10, which is 21 out of 100. And the probability of selecting a blue followed by a blue cube is going to be equal to 7 out of 10 times 7 out of 10, which is 49 out of 100. Okay, so what I want you to do, this is our first probability tree, is to record this information. So hit pause, copy the tree diagram down. Once you're done, hit play, and we'll move on. Okay, and for your notes, it's worth noting that at the end of the branches, we place the outcomes. So blue, blue, red at the end of the branches. And on the branches, we place the probabilities. So we always write it like that. And we multiply along the arms. So some notes for you to complete this question. So hit pause, make those notes. Once you've done that, hit play, and we'll look at another example. Okay, with this example, Rebecca has 9 colored beads in the bag. 4 of the beads are black, the rest are green. So 4 out of the 9 are black and the rest are green. She removes the bead at random, notes the color, and then replaces it. So we're still with independent events. She's replacing them. So there are 3 questions. Draw a tree diagram showing all the possible outcomes. Then calculate the probability that she chooses 2 green beads. And then calculate the probability she chooses a black followed by a green bead. What I want you to do now is to sketch the tree diagram and have a go, and we're going to go over the 2 questions. So hit pause, have a go at sketching the tree diagram, very similar to the one we just did. Once you're done, hit play again and we'll go through it. Okay, so let's have a look then. So in the first instance, Rebecca selected either a black or a green bead. 4 of them are black, so probability of selecting a black bead then is going to be 4 out of 9. Probability of selecting a green bead is 5 out of 9. And she replaces these beads back, and then she selects again. So same probability, 4 out of 9 and 5 out of 9 for green, and 4 out of 9 for black, and 5 out of 9 for green. Okay. So we've completed the first bit, which is to draw the tree diagram. Next, we will need to calculate the probability that she selects 2 green beads. So a green followed by a green, which is that one, a green, and followed by another green. So probability of green and green, that's BI. Green and green is equal to, we multiply along the branches, so 5 out of 9 times 5 out of 9. And that gives us 25 out of 81. And then in II, black, then a green bead. So we're going black bead first and then a green bead. So it's going to be probability of black and green. It's going to be equal to 4 out of 9 times 5 out of 9. Which is equal to 20 out of 81. And I forgot to write, that's BII. Okay, so we've got a question 1 completed. Hopefully you got those 2 answers. Hit pause, make any corrections. When you're done, hit play. We'll look at another example. Okay, in this example, question 2, Peter tosses 2 coins. Draw a tree diagram first to show all possible outcomes. And then B, use your tree diagram to find the probability of getting 2 heads or a head and tail in any order. Okay, so hit pause, have a go sketching the tree diagram, have a go at the questions. When you're done, hit play and we'll go over them. Right, so we want to sketch this tree diagram. He's tossing 2 coins. So in the first coin, when he tosses that, the probability is going to be a head or a tail. And then he repeats that with the second option. So you could get a head or a tail. And then with the second coin, again, head or a tail. So we're going to say that it's an even coin. So it's going to be, chance of getting a head is a half, chance of getting a tail is a half. And the probabilities are repeated then. So probability of getting 2 heads is that one and that one. So that's probability of H and H. That's equal to a half times a half, which is a quarter. The second one is a bit of a strange one. It says a head or a tail in any order. Well, you could have a head, then a tail. So probability of a head and the tail is equal to, again, a half times a half, which is a quarter. But you could also have a tail, then a head. So probability of a tail and a head is equal to, again, a half times a half, which is a quarter as well. But because the order is irrelevant, you've got to add the probability of getting a head and a tail, or a tail and a head. So probability of H and T, any order, is equal to a quarter plus a quarter, which is a half, or 2 out of 4, which is a half. Okay, so hit pause, make any corrections necessary. Once you've done that, hit play, and I want you to have a go at another example for me. Okay, in this question, Peter and Becky are going to run a race and then play a tennis match. Probability that Peter wins the race is 0.4. Probability that Becky wins the tennis is 0.7. So using that information, complete the tree diagram and then use the tree diagram to work out I and II. So hit pause, have a go. Once you've done that, hit play and we'll go through these 2 questions. Right, so in the race, the probability that Peter wins the race is 0.4, which means that the probability that Becky wins the race is what's left over out of 1, because the total probability adds up to 1. So that's going to be 0.6. Probability that Peter wins at tennis is going to be the total up to 1, because Becky's probability of winning is 0.7, so that's going to be 0.3. And we repeat those probabilities here, 0.3 and 0.7. Okay, so I is the probability that Peter wins both events. So the probability that Peter wins the race and then goes on to win tennis is going to be probability that Peter wins both. It's going to be given by 0.4 times 0.3, which is 0.12. And then we have in dotty 2, probability that Becky loses the race but wins the tennis. So she loses the race, that's going to be 0.4 there, and then goes on to win the tennis game, which is down here. So probability of Becky loses race and then wins tennis is given by 0.4 times 0.7, which is going to be 0.28. Okay. Hit pause, make any corrections, and we'll move on to dependent events then. Okay, so this example is an example of a dependent event. Okay, so one event depends on what's happened in the other event. So here Rebecca has 9 colored beads in the bag, same as before. 4 of them are black, the rest are green. She chooses a bag at random from the bag and does not replace it. So the selection in the first instance is going to affect what happens in the second selection. She then selects a second bead. So draw a tree diagram showing all possible outcomes. So again, in the first instance, it could be a red or a black or a green bead. And then in the second instance, again, it could be a black or a green bead. Now, when she first selects them, there are 9 beads, 4 are black, so the chance of selecting a black bead is 4 out of 9. The chance of selecting a green bead is 5 out of 9. Now, because she's not replaced it, we're now left with 8. Now, if she'd selected a black bead in the first instance, that means that we are now left with 3 black beads out of 8. So the chance of selecting a black bead is 3 out of 8. And the chance of selecting a green bead, we've still got 5 of them, so there are 5 out of 8 left. And you can see the total adds up to 1. 3 plus 5 gives us 8 out of 8. If she selected a green bead in the first instance, that means there are only 4 green beads left. So the chance of selecting a green bead is 4 out of the 8 that are left. And she selected green, so there's still 4 black beads out of the 8 that are left there. So that's how we work our probability for a dependent event. So what I want you to do now is to, we'll work this together. Probability of selecting 2 green beads, green in the first instance and then green in the second. So probability of green and green is going to be equal to 5 out of 9 times 4 out of 8, which is 20 out of 72. And then probability of selecting a black bead first, followed by a green bead. So a black bead first, followed by a green bead. So the order matters. E plus G is equal to 4 out of 9 times 5 out of 9. Sorry, 5 out of 8. 4 out of 9 times 5 out of 8, which is also 20 out of 72. Okay, so hit pause. Copy the example down. Once you've done that, hit play, and I've got some questions for you to attempt. Okay, so we're going to be practicing skills on questions 4, 5, and then we're going to move 6, and then move into developing fluency. Okay, good. Good luck.